Hello, everyone, and welcome to the A&M Pathways webinar series. Today, we are going to focus on future-proofing the enterprise, building secure networks for the AI era. My name is Amanda Deshuk. Before we dive in, we have a few housekeeping items to go over. Today's webinar will be recorded. We'll send you the link after the session so you can share the content with your colleagues or review it over again. We encourage your questions and comments throughout the webinar. Please use the chat at the very bottom of your screen. I'll be monitoring it, letting Frank know we have those questions coming through, and we'll hold it for the Q&A portion towards the end. So feel free to chime in, add some questions, anything that you guys may have throughout this webinar. Right now, I'd like to introduce our presenter, Frank Maisano, Solution Architect over at A&M. The floor is yours, Frank.
Thank you, Amanda. Appreciate that. So as mentioned, we're going to talk about secure networks. So thank you for attending today. And let's see if this slide will advance. That's one thing we didn't check. Okay, so really simple agenda for today in the sense that there's a lot we can wrap up in just a couple of agenda points. So we want to highlight first why are secure networks important? Why are they top of mind today? And then what are some of the key pillars that we can use to build secure networks? And well, AI, of course, is important, right? So AI is going to be part of our conversation today. We want to look at how AI is being used by threat actors to compromise networks, to come into networks. And we want to know how some of the modern tools can help us to create a better defensive strategy, even using AI. So we'll see how AI is kind of blended in throughout our discussion today. For those of you who don't know me, my name is Frank Maisano. I'm a solutions architect. I live in Colorado Springs, and I've been in the industry for about 25 years, been with A&M for about the last 8 years or so. I am a CCIE emeritus on the lifetime path, which means I've been a CCIE for more than 20 years. It's a fancy way of saying, too, that I don't have to take the test anymore, so hooray for that. But I enjoy working with customers, helping to build solutions to their networks. You can see some of my core focus areas, but as a generalist architect, I do spend time in all different areas of technology and really enjoy working on those custom fit solutions, you know, those challenging use cases and trying to come up with something creative to address them. Here in Colorado Springs, we have Pikes Peak on the west side of the city, 14,000 feet up. Here's a nice view, a big perspective of the area. So I thought we'd start with that because we want to start with a high level view of why secure networks. So a couple of things come to mind when we think about why secure networks are so important now. You know, it used to be, you know, if you've been in the industry for a while like myself, the concept of securing a network was really illustrated by the castle and moat philosophy, right? You remember the castle has the moat, and so we trusted everybody in the castle. Everybody came in to work. They worked from the office, and we put a firewall there, and we called it good. But today, networks are so distributed, it makes security a top-of-mind concern because there's a huge attack surface. And when did this happen? Well, really around the time of COVID, when everybody was told, go home and work from home. And ironically, it seemed like that was in the news today. In Europe, announcements were made similarly, go back to home because of the energy crisis. But what does that do for networks? Well, we have people attaching to the network from their home, from the local coffee shop. We have them attaching across the state, perhaps, that we're in, maybe across the country, even across the world. So the attack surface is massive. And then we think about the data centers. We have primary data center, backup data center. We have colo facilities. We have cloud that we're connecting to, and sometimes even multi-cloud. And then we have the SASE connections. And it seems like more and more things are just distributed everywhere. So we, as with network engineers, we can't just think about connectivity anymore, but we have to look at every element of how people are connecting and where our assets are and how to secure those. How about AI? AI has already been in our presentation once. It'll appear again and again. But AI threats are making it more challenging to secure our networks, and we have to be on top of it because the threats are evolving, right? Think about phishing for just a moment, and not phishing in the stream like you would in Colorado, but phishing as in phishing emails. It used to be that a few years ago, or even maybe just a year or so ago, we could tell people, look out for the bad things in the email and just avoid it. right? There was bad spelling, there was bad grammar, and maybe even the whole tenure of the email felt like it came from a whole different organization, possibly even like a different planet sometimes. And it was like, yeah, just don't even click on it. That doesn't even look real. But what about today? Well, with artificial intelligence, where people are correcting the spelling errors, they're fixing all the grammar, and using tools like agentic AI, they can comb sites like LinkedIn and make the email look like it's hyper focused for you as an individual. So people are being duped by these more and more. And that means people like these threat actors can actually get into our networks easier and easier. There's also zero-day exploit detection, where people are running zero-day exploits with AI engines and machine learning and attacking the edge of the network and at rapid speed discovering those zero-day vulnerabilities and being able to penetrate into networks. So we have to think about that when we're talking about how we're going to secure networks. And as if those weren't enough, don't we have our operational challenges? We have a hard time finding the right staff with the right skills. We have to deal with the complexity of compliance and regulatory standards. So all of these things coming together, we have to rely upon the network to be more secure than ever. So how can we do it? Well, in today's discussion, we're going to hit on 6 key pillars of secure networking. And each one of these plays a role in supporting the idea of maintaining a secure stance, even in an AI era. Now, as we go through this, you're going to see that there are some overlap between these. As we look at Hybrid Mesh Firewall, for instance, it's going to create better visibility for us. As we talk about segmentation, we're going to pivot back to identity and see how that can fit into what we're doing, and also how automation is important. So as we talk about these different pillars, we'll see how it really brings together a unified solution, a unified approach to securing networks. So we'll go through each one of these, and hopefully we have enough time to get through them all. So here we go. First one, identity-driven access. Now, when did this really come about? When did we really start challenging people on identity to come into networks? Well, wasn't it, again, that same COVID era? When we sent people home, we realized that having them VPN into the network and just trusting their network, trusting who they were, trusting their device was punching massive security holes into the network. We couldn't continue to do that. So the industry pivoted and we ended up with new architectures like SASE and SSE. And as those architectures came up, what happened? Well, we started challenging people on the edge of the network before they even got onto the network using things wrapped around identity. So we start asking people, who are you? Well, why are you coming onto the network? Where are you trying to get to? And what does your device look like? Is it safe to have you on the network? And this is really important as we consider ways in which to make our networks more secure today. We can't just simply trust based on IP address. And we're going to bring this concept into the campus when we talk more about segmentation with one of our other pillars. But that's one of the things we're lacking in. Identity has become a very powerful tool for security, but are we using it in all aspects of the network? Now, we did use, or maybe you have used at some point, a NAC solution, 802.1x. And while it's true, this has been very successful in the wireless deployments of networks, we're still lacking in many cases on the wired side. So can we wrap that identity back in and drive a more secure network? That's what we want to look at when we're talking about this. Now, as such, identity has become a very complex thing, right? When we talk about identity and access management, it's really a whole program all by itself, isn't it? There's many things that make it up. And some of these things we appreciate and some of them kind of annoy us, like multi-factor. I mean, we all have experienced multi-factor. And while we appreciate that it's really solid and good because it helps to prevent, even if someone steals our credentials, it helps to prevent them from getting into our network. It's kind of annoying, right? Put in the 6-digit code, or do you have this push notification on your phone? You've got to tap every single time. But it's huge, right? It's very important. And MFA is finding its way into all aspects of connectivity that involves identity. And then single sign-on is great too, because it gets rid of people having to maintain so many passwords, and device management where we're using MDMs and making sure that device posture is checked. There's really a whole program around this. And so as we think about identity and we're securing networks, do we as an organization have a program looking at all of these different tools and aspects of identity? This is something we've seen at A&M as more of a use case or a need in our customers' environments. And so we actually have a workshop built around identity. And that's something we can help you with if you want to dive deeper into what are you doing today around identity, and where are the gaps, and where should you go next? Because there certainly is a lot there. So that's pillar number one, What are we doing with identity and how can we improve it? Pillar number 2 is Hybrid Mesh Firewall, or HMF. And maybe you've heard the buzzword, it's been around for a little while, but what is it not? It is not a hardware solution. So you can't call up your Cisco account manager and say, hey, I want to buy the latest 9300 Hybrid Mesh Firewall for my environment. Hybrid Mesh Firewall is not a device, it's a framework, it's an architecture, just like SSE or SASE. In fact, it's the next iteration of those technologies. Because what happened with SASE and SSE is we had a great model that worked well for remote users, but it lacked visibility into the on-prem piece. So Hybrid Mesh Firewall takes the architecture of SASE and expands it to include things like on-prem firewalls, virtual firewalls, and so forth. And it begins to stitch all of these together. So really, Hybrid Mesh Firewall is part of an evolution of security. So again, rewinding the clock, we had perimeter security, the castle moat theory, right? One firewall, everybody comes into the office, we're protecting things. We had to re-architect with the COVID era. We had to come up with something different. So with SASE, we ended up with a cloud-delivered security architecture that came with huge benefits. We were able to really start to enforce zero trust. It changed our whole philosophy and mentality towards security. We pushed things out to the edge, like we talked about with identity, and we began to run services in the cloud like CASB services or DLP, Secure Web Gateway, different things like this to actually stitch the security in where people were attaching. And then we have visibility because everything is running in the cloud. Wonderful, except for the fact that there was still a lost domain. We're still managing everything on-prem separately. So hybrid mesh is now taking the on-prem components, even the cloud components, and stitching more of this together, giving us a modern approach to how we're firewalling or securing our network. Here's just another angle, kind of saying the same thing. We come to the market, or the market comes together with a centralized policy management engine or a fabric that stitches all of these different services together. And with one fabric and one policy engine, we get great visibility. Also, AI comes to play, right? So as this next iteration takes place, AI is stitched into everything, and we start to gain the advantages of having artificial intelligence on the defensive for our networks. Now, what does it look like from an architecture standpoint? Well, I generously stole this from Cisco, just to put something up here to talk through. I like architectures because they help us to visualize all the different components and how they stitch together. Now, you could pull something similar from other manufacturers like Fortinet or Palo Alto, different ones who are promoting a hybrid mesh firewall solution, but we'll just use this one for an example today. It starts here in the center with what Cisco calls the security cloud control. So this is that entry point. This is the common control plane. This is your policy engine. This is where you're collecting your telemetry, right? One place to land and then start to see and configure everything else. Now, this name, of course, is just a Cisco name. Fortinet will have their own name. Palo had their own name, et cetera. So what is the first tenet, or what part of this is over here? Secure access. As we mentioned, the SASE or the SSE component was the original birth of this cloud-based security concept. So it's still part of what we're doing. So this element exists off to the side. It's still allowing us to handle our remote user access and what they can access and how they can access it. But additionally, now we're seeing all the rest of the security come in. So whether it be a firewall on the edge of a campus or a branch location, or a firewall that's the north-south controls of our data center, or possibly even inside the data center as an east-west firewall, we're bringing all of the policy and telemetry into this central point, along with what's happening on the cloud edge. We also have our virtual firewalls for our cloud connectivity. And then something else Cisco is doing specifically is driving all the way down to what we could call the switching layer, both in the cloud environment and in the physical environment. So these smart switches you see here are actually, we could say, firewall on a switch. So these allow us to do advanced firewall type functions, allowing us to lock down potentially compromised machines or workloads inside the data center through the security cloud control. Now, we did mention that AI is part of all of this. So AI is allowing us to do behavioral analytics and be able to see what's happening end to end. So for example, if we had an employee with a laptop and they were starting to give indications of compromise, and we're tracking that from our secure access platform. Well, now if that person closes their laptop and comes on-prem and opens up and starts working again, we can correlate data. We can see that's the same thing we were seeing earlier, and we can start acting on it. So we can see how AI is going to be a huge player in bringing everything together, helping to detect anomalies, helping us to improve our policies. And even with AI type agents, we can ask questions about what's going on inside of our fabric and get answers that help us. So Hybrid Mesh Firewall, if we haven't already had the conversation, we probably want to start having it because it's the next iteration of what we're doing around SASE or SSE. Pillar 3 is segmentation. This is another thing that's really important. And I thought this statistic was kind of eye-opening and somewhat alarming. What it's talking about is something called breakout time. And you can see in the graph that in 2021, the breakout time was 98 minutes. And as of late 2025, when this report was completed, it's down to 29 minutes. This represents a 70% drop. But what is breakout time? Well, breakout time is the time between when an attacker initially compromises a machine in our network to their first lateral movement to other systems in the network. Now, some security people are going to call this the speed to compromise. And you can see 29 minutes is a very short window. So how do we protect against this? Well, zero trust philosophy is going to tell us that we have to assume a breach, or we have to assume that an attacker is going to get to this point. Obviously, we're going to do everything we can to stop them before they get in. And that's some of the previous conversation we just had, right? Identity-based access is one. But if they do get in, or when they get in, we're stopping their lateral movement is critical. And that's where segmentation comes in. And we've been familiar with and we've used what we call macro segmentation for a long time, where we've built a firewall between VLANs or put a firewall between VRFs, or have different zones or enclaves inside our data center where we filter between them. That's all great, but it doesn't stop the attack from moving laterally and causing a lot of damage. For example, if VLAN 10 is protected from VLAN 20, but each one has 100 servers in it, if VLAN 10 gets compromised on one server, the other 99 are exposed. So we often hear nowadays people talk about trying to figure out microsegmentation, right? So if that one machine gets compromised, how do I isolate that one machine? And there's some great technologies around this, not necessarily network-based yet, although Cisco's firewall switches that we talked about earlier are kind of a first play at that. A lot of microsegmentation in the data center is better served by agent-based solutions like Cisco Secure Workload or Illumio or Akamai, custom-made solutions that are really drill into what's happening on the machine and blocking any other communication except for what that one machine needs to talk to. That's great for the data center. But what about for the local area network? How could we stop malicious payloads from moving around everywhere on the network? Well, this is where we want to start taking segmentation into the network. This was done in the past with technologies like MPLS, for example. Large universities might have used MPLS to protect the College of Engineering from the School of Medicine, for example, keeping them completely isolated from each other. But manually configuring a IP MPLS backbone on your campus and maintaining that would be overwhelming. Well, nowadays, a lot of people have interest in VXLAN and EVPN technologies, and there are software-defined networking controls that have come out to help us do this. Again, in the Cisco world, this is done through Cisco Nexus Dashboard, can help manage and control this VXLAN, EVPN control plane and monster, we could say. But other companies like Arista and Fortinet have similar solutions around this concept of building out a campus fabric, which can help us to isolate and control traffic on the network. Another thing that Cisco has come to market with is the scalable group tags, or the SGTs. And these we could think of kind of like as a badge. You know, a person who has a physical badge to walk into a building, they can only badge into certain rooms and have access to certain assets and resources. Well, similarly, when a person comes on the network, they receive a tag that only allows them to gain access to certain applications or servers. This could be rolled out as a separate entity, kind of something Cisco calls TrustSec, or it could be part of Cisco's software-defined access. But whether it's Cisco or some other manufacturer, the goal is to get down to a point where we're checking people's identity and moving the security accordingly. So that's what this is showing here. We want to kind of see if we can shift away from the old way of building networks and securing them on the campus side and looking at ways to actually use identity, context, and policy to enforce security at the network layer. This is often accomplished through some kind of a fabric. It's going to make it much easier for us to do these types of things, to obfuscate the underlying subnets and IPs and get away from building constructs that way and building them with a new network model. We'll talk a little bit again more about this as we move forward with automation techniques, right? But the goal is more segmentation, smaller blast areas, and if we do get compromised, this is going to help us to keep our network as secure as possible. All right, pillar number 4. We can't secure what we can't see. So we need to have good visibility. We need to be able to see what's happening. Again, the zero trust tenet or philosophy is we assume breach. So if we assume someone is already camping on our network, what can we do to see it? How can we make sure that we can act as quickly as possible if something malicious starts to happen? Well, it's going to come from collecting good telemetry across the network. So we know we can use things like NetFlow, IPFix, SFlow. We know from inside of our firewalls, there's a ton of flow data and information that can be collected. So what are we doing about gathering this data so that we can act on it? Now, it is true that there's a lot of encrypted data, but with machine learning and advanced algorithms and different ways of approaching data, we can see that there are solutions around looking into encrypted traffic without having to decrypt everything. And once we have all this data, what do we do with it? Well, we want to put it in a place where we can analyze it, where we can correlate it and make some sense out of it. So whether it be the network infrastructure, the cloud, or the on-prem security infrastructure, are we streaming all of that telemetry somewhere where we can then parse it, analyze it, and do something useful with it? Of course, this is going to be some kind of a SIM solution. Maybe you're thinking Splunk or Logarithm. Absolutely. Those are some of the key players. But we want to get some sort of a data lake going and be able to do something intelligent with it. You know, as we look at some of these points over here on the right, we can see that if we have all of that data, we can enrich it, right? We can start to correlate information from one side of the network to the other. Once we correlate data, we can prioritize, right? So if there's just a bunch of noise, we can filter it out. But if there's something important, we can bubble it to the top. And then again, with more automation and different processes, maybe we have the system automatically act on things or provide a guided response to help lock down and control some kind of malicious activity that's taking place on the network. With a solution like this, with this visibility play, we can get beyond just seeing that an isolated log message that might tell us that a port scan was detected or a login anomaly was detected. And we can get a better story, something like maybe user X authenticated from a new location and accessed the sensitive app and initiated an unusual lateral movement in our network. That's where we want to get with the visibility. And this visibility is a key pillar because it helps us to see what's going on. We can see the who, what, where, and the behavior on the network. Thus, we can be more secure. All right, pillar 5, post-quantum cryptography. That's a little bit hard to say, but it's an important thing to talk about. Maybe you've heard this from some of your manufacturers talking about post-quantum ready hardware. And why is this important? What's happening in this world? Well, we could spend probably a couple of days talking about quantum computing and its impact on cybersecurity and so forth. But to try to boil this down into just a few minutes for this presentation, think about what happened in the past when we moved from things like DES and triple DES to AES. If you were networking at that time around the early 2000s, you know that we were starting to have to look at different hardware. Right, the hardware was needed to be upgraded to handle the more advanced encryption and security algorithms. For some devices, that meant installing a hardware accelerator. Maybe you remember doing that on some routers back in the time, right? So everything was hardware driven to support the crypto. Well, we're experiencing another generational turn in this same way. Post-quantum computing is going to require us to use different algorithms on our devices to secure them. So post-quantum computers will be able to possibly compromise the handshakes between our secure connections and break them down and allow our data to be scavenged. So in that case, we need to run tighter and stronger algorithms on our security devices, on our secure connections to protect them. Now, if we run those algorithms today, the problem is that they're going to drive higher CPU, higher latency, and lower throughput. Now, this is at scale. So when we're talking at the enterprise level, we need to look at new hardware that can support things like our IPsec VPN connections, or maybe our DCIs if we're running them over public networks, or cloud connectivity, right? So we need new hardware. Now, that doesn't mean we need to rush out today and like go rip everything out, replace it, but we just need to be thinking about it, because what's going to happen is eventually this type of computing is going to be available to people who want to compromise our networks and grab our data. If you look it up, you'll see something called Q-Day online. Q-Day is the unspecified date in the future when it's estimated that quantum computers will become powerful enough to do these types of things. Google says this could be as early as 2029. Others estimate it could be sometime in the 2030s. The point we want to take away today is that's not very far in the future. So if we're going to refresh hardware now, we need to start asking the question, is this particular hardware I'm purchasing post-quantum ready? Now, another thing we talked about, whether or not how urgent it is and what it means for today. You might have also heard about harvest now, decrypt later. That's another mentality, something we see online and in different articles. So what that means is that today people are grabbing some of this encrypted data and hoping that in 3 or 4 or 5 years, they can break it open and steal the data. So today, it's not a bad time to start deploying some of these newer pieces of hardware that will secure the connections better and make it so that our data is protected. So post-quantum crypto is something we need to be thinking about as we plan forward. Our sixth and last pillar is automation and consistency. Go back to our conversation or our discussion point about segmentation, right? How are we going to segment everything? It's by maybe a campus fabric. Campus fabric could be very complex and difficult to do if you're doing it manually. So we need some kind of centralized policy engine that can drive this. A great example is what people are doing with SD-WAN today. And many of you on this call are probably already using SD-WAN in your environment, or you're very familiar with it. And SD-WAN gives us what? A single control point where we can program the policy, we can program our network intent, as it were, and then it goes out and behind the scenes creates all the complicated BGP or OMP or OSPF or whatever it is, the underlays and overlays and all the different technology, it's done automatically for us. So we're driving policy and intent without bringing in complexity and difficulty for management and operations. So take the SD-WAN concept and bring it on premise. We need some kind of software-defined networking play that can help us to build that campus fabric. And the campus fabric will help us drive toward a more secure and segmented environment. The goal, again, is to get to this point where we're thinking in terms of we want our HR users to access only HR resources. We don't want to be thinking in terms of how do I isolate VLAN 10 from VLAN 20 and what ACLs do I need and what VLANs map where and what firewall rules need to be. No, we need to get away from doing all that manually and automate that process. It creates a loop. Ideally, this intent-based networking starts with policy, it moves into automation, the configuration gets pushed out. We have to have some kind of a verification engine because we don't trust our machines completely yet, but we want to verify those configurations. And then we want to have visibility so we can continue to improve the cycle. So we can see how this brings about a more consistent policy, less room for manual error and configuration issues that can lead to security compromises on the network. So with a few seconds to go, what did we learn today? What did we talk about? Well, the reality is that we need secure networks because networks are distributed, the threats are sophisticated, they keep coming. The approach is still the right approach with zero trust. Trust no one, trust nothing, keep validating. Remember that security is continuous. And as we bring it to the network, what is it going to require? Well, maybe some or more of these 6 pillars we talked about today. And if we were to focus on one particular one, maybe hybrid mesh firewall is a good place to start. Many of us are probably already using some kind of a SASE architecture. So evolving that will continue our segmentation play. It will continue to give us better visibility. It drives automation through policy across the entire security network fabric. And then maybe as we move forward, we can start to explore other opportunities in the world of segmentation. We can get deeper with identity. That's a very important part of everything we've talked about. And we can help to support a more secure network environment. How can A&M help? We have several workshops, some listed here. There's one, I don't have the white paper for it, but it's a workshop on identity mentioned earlier. So any one of these workshops, we're happy to dive in for a couple hours with you and your team, peel back the layers of what you're doing today and what you could do tomorrow to make things better. And aside from our workshops, we also have our pre-sales deep dives where you can work with your local solutions architect to go into deeper consideration of any of these different ways in which you can bring secure networks about. So thank you very much for your attention. Appreciate that. And Amanda, how are we looking for questions or comments?
Good. We actually do have a question from Jacob. Jacob did ask, still new to the cloud side of things, but when you talk about virtual firewalls on the cloud side, are you only running the built-in ones or also running VM software ones alongside?
Yeah, great question. I think it kind of depends. Obviously, that's the answer always when it comes to networking. But what we see happen is for people who may be just getting started and kicking the tires, using a cloud native firewall might make sense. But more often than not, we find people wanting to align their firewall with their greater firewall strategy. So if you are, say, for instance, you use Palo Alto a lot in your environment, putting a Palo Alto firewall in the cloud makes a lot of sense because you can bring that telemetry all together and your policy is driven from a common control point, like Panorama, for instance.
Thank you, Frank. And then Justin did ask, will you be sending out the recording? I want to share with my team. And yes, it gives us about 20 minutes to kind of upload the video. And then we have the on-demand version on YouTube. So I'll be emailing that over to you guys as well as Frank's email. So if there's any additional questions that you guys may have, we'll send that over. So thank you all for joining our A&M Pathway series. We will be sharing out that recording and we'd also love your feedback. So there'll be a quick short survey that will pop up at the end of the session. If you guys can just chime in, share your input so we can bring some relevant content for our next webinars. That helps us, to continue these throughout the year. So thank you everyone for joining. Thank you, Frank. And this was great.
Thank you.
Thank you. Bye-bye.